can say generalized equation of ellipse, which was x equal to xc plus a cos u and y equal to yc plus b sin u. Okay, u is a parameter which is nothing but the angular incrementation, okay, with respect to the coordinate system, that is x axis in anti-clockwise direction. And we have determined an equation for an incremental point with respect to the previously defined point on the curve. Okay, the parametric equation for this incremental point was xn plus 1, which is the x coordinate of the incremental point, that is equal to xc plus a cos u into cos of delta u minus a sin u into sin of delta u. Okay, whereas u and delta u, both these terms, they'll be one and the same. Okay, and yn plus 1 is equal to yc plus in bracket yn minus yc into cos of delta u plus d by a into xn minus xc into sin of delta u. Okay. Now let us study one more condition of ellipse. The ellipse is inclined at an angle alpha, okay, with respect to x-axis. Okay. This is yw and this is xw. That is the working coordinate system. Now we have to study with respect to the model coordinate system. Okay, this is our x-axis and y-axis. The ellipse is inclined at angle alpha with respect to the x-axis. So in this case, we have to determine the parametric equation, okay, for an ellipse which is inclined at some certain angle with respect to x-axis. Okay. So ultimately what we have to determine the coordinates of any point on the curve when the ellipse is at some inclination to x-axis. Okay. So we have to determine this distance. This will be the x coordinate of the point and its vertical distance. This will be the y coordinate of the point. Okay. So we have to follow some certain trigonometric rules in order to find out the coordinates of an ellipse which is inclined at some angular orientation with respect to x-axis. Okay. We know that for an ellipse, okay, the y coordinate of this point is equal to b sine of u and the x coordinate is, so I'll drop a perpendicular. Okay, so this is the y coordinate and a cos u is the x coordinate of this point on the ellipse, okay, as per the generalized equation. Now let us see some trigonometric, can say, relations. Okay, so I'll draw a line parallel to this x. Okay, and let us determine okay, now consider this triangle. This is 90. So since this is also 90 degrees, it is a perpendicular to the x-axis. Okay, hence this will be 90 minus alpha, and this angle will be alpha again. Okay, so I'll redraw the same triangle. This is the point P on the curve, which is making an angle of alpha now. We know the distance, the vertical distance, which will be now considered as the hypotenuse of this triangle, that is b sine of u. Okay. So we have to determine this vertical side or adjacent side to angle alpha. So this is nothing but cos of alpha, which is equal to adjacent upon hypotenuse. Hence, this adjacent side will be equal to cos of this angle multiplied by this side. So the value of this side will be b sine u into cos of alpha. Okay, so I have this distance. Okay, so this is nothing but the height from this horizontal line. So this is b sine u into cos of alpha. Okay. Now I have to determine this vertical height. Okay, so we all very well know that yc, okay, is equal to the height of the centroid or the axis, okay, from the model coordinate axis. This is equal to yc. Okay. Now we have to find out this distance. Now again consider one more triangle. Okay, I'll drop a line perpendicular from this point on the x-axis. So I'll get one more triangle. Okay, this is PC. Okay. Now this slant edge, that is nothing but the hypotenuse of this triangle, is equal to a cos of u. This is a cos of u, and this is the angle of inclination which is made by this line with respect to x-axis. Okay, that is nothing but the inclination of ellipse with respect to the horizontal. Okay, so we have to determine this edge, the side, okay, the vertical distance. So this will be equal to sine of alpha. So we know that the sine of alpha is equal to opposite upon hypotenuse. Hence, the opposite side will be equal to sine of alpha multiplied by the hypotenuse. So the distance will be a cos u into sine of alpha. Okay. I'll write it over here, a cos u into sine of alpha. So I have now the y coordinate of this point, which is inclined or which lies on the curve which is inclined to the x-axis. Okay, so the total distance of the y coordinate will be yc plus a cos u into sine alpha plus b sine u into cos of alpha. Okay, so we have determined first the distance of yc, sorry, the y coordinate of this point, which is equal to yc plus a cos u into sine alpha, the vertical distance, a cos of u into sine of alpha plus this vertical distance again, b sine u into cos of alpha plus b sine u into cos of alpha. Okay, that is the x coordinate of this point with respect to x-axis. So I have with me the distance of, this is the center point, I'm sorry, xc. Okay, so I'll have to simply add up this distance so that I'll get the x coordinate of this point. Okay, that is p. Okay. Now, since we have determined for this triangle, okay, the distance of this vertical side, so let us determine it for horizontal so that this distance will be added in. Okay, this is actually the distance between these two lines. Okay. So this edge, the distance will be the sine of angle. So it will be b sine of u into sine of alpha. B sine of u into sine of alpha. Okay. I'll write this distance over here. This is b sine of u into sine of alpha. Okay, and finally we'll determine this distance again from PC till this point. Okay, from PC to this point. So this is the cos of angle. Okay, so this side will be equal to a cos of u into cos of alpha. A cos u into cos of alpha. Okay, so I have now the distance a cos u into cos of alpha, which is the distance between these 2 points. A cos of u into cos of alpha. Okay, so we'll simply add up this distance to get the distance of point P, x coordinate of point P with reference to the vertical axis. Okay, so this will be xc plus. Now I have this total distance a cos u into cos of alpha, whereas I need the distance up to this line or this projection. So I'll subtract b sine u sine alpha minus this term. Okay, so that I'll get this distance. So the equation will be xc plus a cos of u into cos of alpha minus b sine u into sine of alpha. B sine u into sine of alpha. Okay, whereas z coordinate will be equal to zc itself. Okay? There won't be any change in this coordinate. Okay? So these changes should be made in the incremental equation of the ellipse when the ellipse is inclined at an angle alpha with respect to the horizontal axis or with respect to the x-axis. Okay? So please note down these equations for this condition, that is inclination of or orientation of ellipse at an angle alpha with respect to x-axis. Okay? And the incremental equation, I'll write it once again. So this is the parametric equation. Pn plus 1, xn plus 1 and yn plus 1 for any point on the curve when its axes are parallel to x and y. So xn plus 1 is equal to xc plus xn minus xc into cos of delta u minus a by b into yn minus yc into sine of delta u, and yn plus 1 is equal to yc plus yn minus yc into cos of delta u plus b by a into xn minus xc into sine of delta u, and zn plus 1 is equal to zn. For a point on a curve, okay, that is on ellipse, the first condition is when the two axes are, that is major and minor axis, are parallel to x and y axis. Major and minor axis, they are parallel to x and y axis, and the latter case is when both the axes, that is the major and minor, okay, it's usually the major is inclined at an angle alpha with respect to x-axis. Okay, fine. So let's start with a simple example. problem is an ellipse is defined by the center point eight 12 and has a major radius of 10 units and has a major radius of 10 units and minor radius of 4 units. Minor radius of 4 units. Okay. Determine the various points on the ellipse. Determine the various points on ellipse in first quadrant. In first quadrant, if the increment between each point is 30 degrees, if the increment between each point is 30 degrees, okay. Assume that ellipse is oriented such that the major axis and minor axis are parallel to x and y axis respectively. Okay. So the condition is major and minor axis, they are parallel to x and y axis. Okay. So we have to determine the points on the curve, that is ellipse. Is the generalized equation. This distance is b sine of u is a cos of u. Now we have to determine the points on the ellipse for u is equal to delta u is equal to 30 degrees. P, Pn plus 1 and so on. So that, and the point lies in the first quadrant. So delta u is equal to 30 degrees. Okay. Is PC the center point of the ellipse. Okay. What else is given? The center point is equal to center point XC and YC is equal to 8 and 12. Then the major radius is equal to 10 units. Okay. So the major radius is equal to A, and this is the minor radius. Okay. It cannot be considered as minor radius. I'll have to draw a circle again inside. This is the minor radius, that is equal to B. So we have A is equal to 10, B is equal to 4. So the first point, that is PXY, that is equal to PN XN YN, will be equal to XC plus A cos of U and YC plus B sine of U. Okay. So we know that cos of 0 and sine of 0. So cos of 0 is 1, sine of 0 is 0. So the coordinates, okay, of xn and yn will be xc, that is 8 plus A. A is, the diameter is 10. Okay, so we have the coordinates 8 plus 10 and yc is 12 plus 0. So En, that is xn and yn, is equal to 18 and 12. Okay, so these are the coordinates of P1 which correspond to value 0, xn and yn. Now for each increment by 30 degrees, okay, we have to find out or trace the coordinates of point P on the curve which lies in the first quadrant. That is for theta equal to delta equal to 30, delta u equal to 60, u equal to 60, let's say, instead of saying delta u, and u equal to 90. Delta u remains constant, okay, that is equal to 30 degrees. Okay. So let us find first value of cos of delta u, that is equal to cos of 30, that is 0.866, and sine of delta u, that is equal to sine of 30, is equal to 0.5. Okay. So we'll prepare a table, okay, in which first column is theta. Okay, that is the angular orientation, let's say, or we can even say this as the value of u. Okay. Then the second one is xn, yn. So for each incremental point, the point that has been derived or defined previously will be considered as the reference point, and the incremental coordinate xn plus 1 and yn plus 1. Okay. So for u equal to theta equal to 0, okay, that is u equal to 0, the coordinates xn and yn are 18 and 12. 18 and 12. Okay. Now these points will be considered as the reference point to determine the next incremental point. Okay. Now we are finding out for theta equal to 30 degrees, that is delta u equal to 30 degrees. Okay. So xn and yn, they will be same again, 18 and 12. For xn equal to 18 and yn equal to 12, the value of xn plus 1. Now again we'll substitute the value in the equation xn plus 1, that is xc plus xn minus xc into cos of delta u minus a by b into yn minus yc into sine of delta u. Okay, so xc is equal to 8 plus xn 18.
सर
Yes,
सर ते खालचं लिहिलेलं दिसत नाहीये, थोडी शीट वर घेता का?
is it okay now?
येस सर.
Okay. xn is 18 minus xc is 8 into cos of delta u is 0.8. B is 4. So minus 10 by 4 into yn minus yc. Yn is 12. Yc is again 12. So this will be 0, or straight away this term will be cancelled directly. So yn minus yc into sine of delta u, that is 0.5, and hence this term, that is xn plus 1, for xn is equal to 18. Okay. So if we consider that this is the angular orientation, okay, of the first point on the curve P at an angle 30 degrees in anti-clockwise direction, so this Pn plus 1, its x coordinate is equal to 16.660. Okay, and yn plus 1, that is equal to yc plus yn minus yc into cos of delta u plus b by a into xn minus xc into sine of delta u, that is equal to yc is 12 plus yn, Yn is again 12 minus 12 into 0.866. So the first term will get cancelled, plus b by a, that is 4 by 10 into xn minus xc. Xn 18, xc is 8 into sine of delta u, that is 0.5, and hence the value of yn plus 1 is equal to 14. Okay, so this was for u equal to 30 and angular orientation equal to 30 degrees. Now for the second point, that is theta equal to 30, 60 degrees. Okay, delta u will remain constant, that is equal to 30 degrees. So now 16.66 and 14, they will be treated as xn and yn to find out the new coordinates of the incremental point. Okay, so substitute 16.66 and 14 as the value of xn and yn to determine the coordinates of the next point. Okay, so let us assume that this is our next point, which is inclined at 60 degrees, okay, with respect to horizontal. Okay, and delta u, that is distance, angular orientation between these 2 points, is 30. This remains constant. So now this Pn plus 1 will be treated as the reference point Pn, and the second point to be determined on the curve will be treated as an incremental point. So substituting the values of xn and yn in the formula for finding out the coordinates of xn plus 1 and yn plus 1, we get the values at as 13 and 15.464 for theta equal to 60. Okay, so we'll have to iterate one more time, that is for theta equal to 90 degrees. Now for theta equal to 90, xn will be 13 and yn will be equal to 15.464. Okay, so I'll write it over here. That is for angular orientation, that is equal to 90 degrees. Okay, so this is just for our understanding. Theta, that is the orientation that we are at. Okay, and delta u will remain constant. So for this point, xn and yn will be 13 and 15.464. Okay, and we determine now the coordinates of a point which exactly coincides with orientation 90 degrees with respect to horizontal, but the we can say value of delta u will remain same, that is equal to 30 degrees. So now this point will act as the reference point, and the point that corresponds to 90 degrees will be considered as an incremental point. Okay, so substitute the values again in the equation to calculate the coordinates xn plus 1 and yn plus 1. We get the values as 8 and 16. Okay, so you can write these values over here. So initially Pn, x and yn, they were 18 and 12. So they were 16.660 and 14, 16.660 and 14. The second point coordinates, they were 13 and 15.464, and the last point that corresponds to 90, the coordinates were 18 and 16. Okay, so this is how we apply the generalized formula, okay, as well as the formula to find out the coordinates of the incremental point on the ellipse, okay, and mark these points on the curve or represent the coordinates on the curve. Okay, so that's all for today.